Alrighty then. Let's go and get started. So for your last official CS repository, because yeah, this is the last one. Next week there's the project week, and then you guys are on the labs. So hopefully you're excited for that. But yeah, for this last repository, we're going to be revisiting a topic that you guys have worked with quite a bit from the web curriculum. We're going to be delving a bit deeper into servers and kind of looking more at how they're actually implemented under the hood. We're going to be essentially building a pretty simple server. So right, the rationale at this point is that you guys have worked with Express a lot, or at least in the web curriculum, you guys probably worked with Express a lot. I don't know how many of you kind of thought Express was kind of a magical library that was doing a whole bunch of stuff under the hood that was abstracted away from you, or just kind of seemed like a big magical black box. Again, as is a very common theme with the CS curriculum, we're going to try to strip away a lot of that magic, that mystique, and kind of get a better idea of what web servers are actually doing under the hood in order to serve files, right? And really, the way I think of it more, it's just like I can totally sympathize with a notion. Like when I first learned about, my first exposure to web servers was through Express as well. And certainly at the time for me, it all seemed like magic. And it seemed like, I remember thinking we started and worked our way up to React. Yeah, right. So there wasn't ever much talk about what Express was actually doing and stuff like that. I know it's taken a while to get there, but finally we're going to try to unravel some of that, right? So again, Express is very likely a black box to many of you, and so it's easy to conflate that and think that it's probably super complicated and stuff. And maybe Express is. I'm sure the Express library itself is very complicated, but my point being is that web servers, if we're just talking about like a kind of bare bones web server functionality without any of the crazy bells and whistles that Express provides you, like asynchronicity with what it provides with, because you could write async await syntax in Express with JavaScript, right? We're not talking about that, or like we're not even really talking about concurrency. We're not really going to be talking about that. So certainly this is going to be a pretty bare bones implementation, but the end of the day, the goal is to give you an idea of kind of just foundationally what the server is doing. I think once we kind of go through this material and you kind of see internally what's actually going on, you'll realize that web servers in and of themselves really are not magical by any means. They're actually pretty simple, I would say. Okay, so at the end of this week, because this is a week-long sprint, so we'll be just like with architecture, we'll be working on this one web server project this entire week and kind of working in different parts of it. We'll have by the end of the week, I should share my screen. Right, so what we'll have by the end is, I've already run make, so it should be fine. When we go and compile the server executable, it'll be just like, it'll just run in a terminal window, just like when you start up a node server. And then we can open up a browser, and the endpoint we'll be using here is the port we'll be using is 3490. So we'll just be able to hit root, get a really simple piece of, really simple HTML page. that the server will just serve to the browser. There's going to be this, well, we're going to implement one endpoint, this one just called /d20. And once we hit that, it'll just, could not find it. Oh, cool. I guess I just found a bug in the solution implementation. Okay, well, I'm sure your guys' will be working, but apparently there are kinks with the solution one. I will have to look at that later. Right, but specifically the point with this endpoint is that it'll just return a response. The server will return a response, and the server will get that request for the /d20 endpoint. It will generate a random number between 1 and 20 using a random number generator, and then just literally return that as plain text in the response. And so then the client would just get and render that. The browser would just get and render that back, is what that's supposed to be doing. Right, so pretty par for the course for what you guys have kind of come to expect so far with web servers. And obviously here we're just returning really simple HTML files. But like at the heart of the matter, this flow is still pretty much what you get even when you return, complex HTML pages that you've written with React and Redux and all that good front end stuff. Right, at the end of the day, what you're still getting back from the server is still just an HTML page, some sort of HTML resource. Obviously, it's way more dynamic and not just purely static like the pages we're seeing here. But again, at the end of the day, that's pretty much all that's going on. I'm not saying that the whole flow of actually traversing the internet and stuff is simple. Of course, there's a lot of infrastructure behind that. I want to talk about some of that. But I guess my point being is that I think it's actually a lot simpler than it first seems to be when we first learn about this stuff. I should probably ask if anyone had questions or anything from the videos first off. We're going to talk about we're going to delve into the topic of when we actually type a URL into the browser here. What we're seeing so far is we type a URL into the browser and some stuff happens. Maybe we're not quite sure what happens yet, and then we get some resource back, right? So we know we have the client and the server, and that something's going on from the client to the server, and then something happens on the server's end. It sends the resource we requested back. The browser renders that. But kind of like what's happening in between there, we're going to talk a bit about that. But before we do that, were there any questions that people had, or maybe any sort of clarification they needed from the videos or anything like that? Try this again. So what if I just did D20 here now? Okay, that worked. Interesting. So does it just break when I try giving another request? Okay. Seems to choke when I try to give it multiple requests in one session. That's interesting. Would it be correct for which protocol serves best? Picture of YouTube, watching a movie on. Oh, you're talking about the challenge questions. Okay. Fast-paced online multiplayer game, making phone calls with the internet. I would say the first three are correct. Actually, it turns out so. When I'm talking about like an application that makes phone calls over the internet, I guess I don't strictly speaking just mean just a voice call, right? So like this kind of encompasses like calls you might make over Skype or Zoom calls. Those I'm kind of lumping them together, but actually it turns out the protocol it's being used for, the protocols as far as what's being used for like this Zoom call here is actually UDP, right? Because there's a large stream of information that's getting basically sent from my machine to your guys' machine, right? Um, it's not just like a single resource page, like again, like the front page of YouTube. Like you just get that once, and then once you have that data, uh, it doesn't need to constantly be updated, right? Like with this call here, it needs to, again, it's grabbing my image, and that is turned to a bunch of pixels, and that always needs to get sent to you guys, on a really fast kind of basis, if that makes sense, right? So in that sense, it's kind of along the same bandwidth requirements as like a fast-paced multiplayer game, right? It's like, yeah, exactly, right, and that is kind of, yeah, the kind of the fundamental distinction, right? Is it that whatever I'm requesting, is it just one thing that I just get from the server, and then that doesn't need to be updated unless I decide to, like refresh the page or navigate somewhere else. But like the page doesn't really get updated unless it's in response to, the end user's like actions or something, right? Like again, like navigating on a web page, sure, then that needs to get updated. But then the update there is just fetching another resource in response to that, right? Whereas with, streaming a movie or making a voice call, playing a game, whatever, there is constantly data that needs to be sent back and forth between the client and the server all the time, right? Because well, like with a game, if any of you play like League of Legends or Dota or even like an MMORPG like World of Warcraft or something, that world, that server that you're in, that your character is in, for example, like that's always updating. If even if like your character isn't moving, other characters in that server are moving, and that's something that the game takes into account when it's rendering what you're seeing on your end of the client, right? So there's lots of updates happening there all the time. Same with a movie, right? Because when you're streaming a movie, you don't have all the movie data. Like you don't just download the entire movie in one shot and then watch it. That needs to keep getting buffered, and so there's data constantly getting sent in order to just stay ahead of where you currently are when you're watching the movie, right? So that's kind of the main distinction. Okay. Perhaps those videos need to get improved, as per what Thomas said. Yeah, that's pretty much correct, Thomas. Does data integrity not matter in those contexts? Stream movie playing MMO, right? So again, Thomas mentioned this a little bit in his comment here. But right, yeah, that's the idea. The idea being that when you're streaming data, um, again, I'm going to use the game example, right? Lag is something that happens. The experience when you're playing is not entirely smooth, and oftentimes that can be attributed to the fact that some data was lost along the way when the streaming was happening. Because again, with streaming and the UDP protocol, again, it's you can think of the amount of data that's getting sent is more like a fire hose. Like it's just spewing out packets of data, and just by the sheer amount of bandwidth of data that's getting spewed out, there's really no way we can check that we got every single one of those packets, that every single one of those packets is correct in terms of its content and stuff, and anything like that, right? Again, just there's so much bandwidth of data that's getting sent in that case that there's no way we can check it all. And so, networks are not perfect. So dropping packets and stuff like that is kind of inevitable, right? And again, this is a little bit exacerbated by the fact that with a UDP stream, again, when there's so much data getting sent, it's way more likely that some of those packets are going to be dropped and not reach the destination that they were intended for. And so that's why you see lag in an MMO or like a League of Legends game, etc. Right? Because some data that would have been required in order to make the game run entirely smoothly didn't get to where it was destined to go. And so that's kind of what that translates to on the user's end when they're actually playing, or maybe some lower resolution if you were in the context of watching a streaming movie on Netflix, right? Sometimes you'll be watching a movie at a certain definition, and maybe all of a sudden, without any prior warning, it'll kind of like drop to a lower resolution for a bit of time and then keep going, and it'll like improve, And also with Zoom calls, sometimes things will cut out, or the quality will drop for a little bit. So oftentimes that can kind of be attributed to the fact that, some packets, some data did not get to where it was supposed to go. And this is the same with TCP, right? TCP in and of itself is not like, oh, it's just the fact that because TCP requires way less bandwidth to do what it's trying to do. TCP in and of itself doesn't actually have any. I mean, it makes better guarantees just because with TCP, because we're sending fewer requests overall, or sending fewer packets overall than UDP. TCP can afford to just be like, we can wait for the client. It waits for an acknowledgement from the client. It waits for an acknowledgement to say that to ensure that the data got there, that the client acknowledged that it got it, and then when at that point TCP is certain that it doesn't need to try and resend the data. Is the idea of connection/connectionless out of scope? I'll say it's out of scope just because I'm not prepared to talk about that. We can talk about that tomorrow if that's something you're interested in. Cool. All right. So let's move on then to the initial topic I had in mind. So this is a pretty good Stack Overflow post on this particular question. Again, what happens when you actually type a URL into the browser? Has anyone been curious about this and kind of just looked this up on their own before? Or does anyone kind of have a good idea of what actually happens when you do type a URL into the browser? Okay, not really. Cool. And certainly, since I'm assuming most of you all are going to be working in some sort of web context or web stack when you finish Lambda, this is probably something all of you should know when by the time you leave here. Okay, so okay, let's kind of walk through this particular answer because I think it's pretty good. And it does start off with a pretty massive disclaimer that this is extremely oversimplified. There's lots of details that are not mentioned in this breakdown. And of course, we're not going to go too much more in depth into what is mentioned here. So yes, there is going to be yeah, there's going to be a lot of fine grained details that we're not going to be talking about. But from a high level, uh, this is a pretty good summary. Okay, so let's just walk through all these steps and kind of talk about what each of them means, right? So again, just for context, again, we uh, our browser is the client. We type a URL into it. It's going to somehow get to a server. That request is somehow going to get to a server. That server is going to fulfill that request and send whatever resource we requested back to us that the browser is then going to render, right? So here's what actually happens. So step number one, browser checks cache. If the requested object is in the cache and is fresh, skip to step number 9. Okay, so let's. Well, we're going to talk about caching more in depth in the second half of this week, and in fact, you guys will be implementing caching functionality into the server. But basically, what this is if we don't know what a cache is basically well, if you think of the word cache, right? If you just think of the word cache with it, not in like a software context, right? I think typically, or at least what comes to mind is me is like a treasure trove, or like or maybe because I've played too many games, like a weapons cache. That's a common term in some types of games, right? And you think of those as like some sort of some storage or some sort of treasure trove, again, in a way, like in those certain games, when you stumble upon a cache, it's like always a good thing, like, oh, more resources, like kind of stuff like that, right? But it's a little bit different here when we're talking about caches in a software context. So in a software context, what a cache is it's essentially it's faster access to what we are initially trying to get, right? So again, when we type a URL into a browser, we are requesting a resource, right? And that we can get that resource from multiple places. Generally speaking, that's going to, again, if we request like google.com or facebook.com, typically speaking, that needs to come from one of Google's or Facebook's servers that they have provisioned in some server farm somewhere. Typically. But that's not always the case. As we're talking about here, the cache is not something that Google or Facebook provisioned for their site resource, right? So essentially, what the cache is it's a source for where the data can be stored that's actually closer and easier for your browser to fetch than going all the way to Google or Facebook servers. And I think a visual probably would help a bit, right? So so if we go, so this box here represents your browser. And let's say, you type whatever into it. So first off, it turns out your browser has a cache associated with it. So if we just imagine that cache like this. So like, for example, if you've ever worked with like local storage as part of like your browser's API, that's a form of a cache. It's essentially a place that's much more local to the client where some data can be stored, right? But the idea here is that, again, as I was saying, so let's say that this represents, let's just call it Facebook servers, right? And if this is where the page or the data for Facebook.com typically lives, this is going to be a lot further away than the cache. So the idea then becomes, if the cache has Facebook's data in it and we request Facebook.com, we can just go here to get it instead of having to traverse further along down the internet to actually get this resource. But that being said, the cache isn't going to start off with this data initially. So a more typical flow would go more along the lines of, let's assume our cache is empty. And the first time we type, so the first time we type Facebook into our browser's URL or into the URL box, it's not going to be in the cache. So we need to go traverse along the internet in order to Facebook servers in order to grab this resource. That resource is going to come back to our browser. Our browser will display it. Before it does that, it will actually also then take that and put it in the cache. So then the next time, because not everyone's addicted to Facebook, but a lot of people are. So the next time you go to Facebook, instead of again having to make that same trip to Facebook server in order to get that resource, first we'll check to see if this cache has it, and we can just grab it from there. Right? It's saving us having to perform more work on subsequent times when we want to go and access that particular resource. That's a pretty kind of general use case for a cache. Right? As we can see in this example here, you get to skip a whole bunch of work if it turns out that that data that you're requesting is indeed in the cache. Skip to step 9. So all this work then it gets skipped if it turns out the data is in the cache. Again, we're going to talk about caches more in the latter half of the week. Again, you guys will be actually implementing one. But yeah, that's kind of the general overarching idea of what's going on there with this first step. Okay, so assuming that the data wasn't in the cache, so maybe we're requesting some resource we never requested before, for example, what has to happen? The browser asks the OS for the server's IP address. Right, and so this needs to happen because at the end of the day, how is a computer able to know how to access this Facebook server? I mean, first off, it needs to be able to identify it, and computers are not nearly as good at understanding strings as they are numbers. So even though we humans will type in, a string or a string URL into the browser, that's not what computers understand. So the first thing that it needs to happen is the URL, whatever that may be. Let's Google. This needs to get translated into something a computer understands. In this case, it's going to get translated into some IP address. Telling it that this is a place where you can go and get the resource associated with this URL. Right, so this translation then, how does this translation happen? Well, this translation is essentially uh, what DNS provides. So I think you all have, heard of DNS. I'm actually blanking on what the S stands for, and it's domain name. Domain name what? Domain name system. Okay. So this is exactly what DNS does. What are you doing here, Patrick? Okay, cool. Anyways, that is probably also a good resource. I haven't looked at that one that Patrick just linked, but I'm sure it's probably also good. So yeah, DNS is on its own is a complex system in and of itself, because the whole point of DNS is that, well, it turns out DNS is this distributed database service that literally just provides these translations. At the end of the day, it's pretty much just a giant hash table with key value pairs being the keys are the URLs, and the values might be those IP addresses. Right? So that's kind of what it would all boil down to, right? Again, being a giant hash table where, google.com would match to whatever an IP address that's valid. Of course, Google will have tons of servers that can give you this resource, so there'll be a lot of valid IP addresses, for example. There might be a whole bunch of IP addresses. But that's essentially what DNS provides you, is this translation. And this isn't the hard part. Just having this essentially hash table with all these key value pairs is not the hard part of maintaining the DNS system. What's hard is that DNS needs to be distributed across the globe such that anywhere you have internet access, you're able to access a DNS server. So that's a huge, complicated distributed systems problem that we're not going to talk about. So again, all we can really care about at this point is that DNS is the service that essentially provides this translation, so that we can then, now the computer understands we're looking for this particular IP. We're looking for the computer with this particular IP address. So that's kind of conglomerated. Steps 2 and 3 are kind of what I was just kind of talking about, conglomerates steps 2 and 3. Because the OS might know the server's IP address, but if it doesn't, it needs to go and perform a DNS lookup and replies the IP address to the browser. And then at that point, once we have the IP address, that's when the browser can open a TCP connection to the server. So I don't actually quite remember how it's done in Express, but certainly when you implement some sort of server, there's probably going to be some line of code in your server code that's just being like server dot bind to some location, some IP address. And so kind of that's what's going on here. So to open up the TCP connection, and just in this one step, that's where all of the stuff pertain to actually how TCP sends an initial well, the TCP handshake happens here, right? So it sends an initial request to the server, and needs to wait for that server's acknowledgement that it got the client's initial request, and then at that point the TCP can actually set up that connection and all that stuff. right? Really, you know, in any of these steps, there's a whole bunch that you could dive into as far as what's actually going on. But again, here, this is where the TCP handshake stuff would all happen in order to actually set up that connection, or UDP if you're going for a UDP connect, if you're performing some sort of if you're using some sort of application that utilizes UDP instead. But here we're just going to assume TCP. So once that connection is actually established, then we can send the actual request through the connection. And as we'll see when we're actually implementing the server, the HTTP sending the actual request, I mean, really to perform step 5 here, this is, as we'll see from when we actually start working on the server code, this is literally just sending a specially formatted string that the HTTP and TCP protocols can understand. It just needs to be kind of formatted in the way that they're expecting. Oh, okay, right. So this particular question is kind of from the perspective of the browser. So between steps 5 and 6, because we say step 6 here, the browser receives the response. So really between steps 5 and 6 is where what we're implementing with the server will happen. So, you know, step 5.5, the server receives that request, figures out what to do with it, figures out what's the appropriate response to make, and then sends the response back, which again, as we'll see, is pretty much nothing more than a specially formatted string. And then that gets received back by our browser. The client receives the response, may close the TCP connection, or might decide to reuse it. That's a little bit application specific. I think what we'll be doing when you work on the server code is you'll be closing the TCP connection every time. Next up, the browser will check that response, basically parse that response string, see if it needs to do anything besides just looking at the body of the response and rendering that. So here's maybe where you will check like status codes that came back from the request. Most notably, there might be redirect status codes, which basically mean this resource has been moved, for example, is a pretty common one. Here's where you might want to go instead, to go and actually fetch the resource you were looking for. So that'll come back as a specific status code, and robust client implementations, if they get that particular status code, will automatically perform another request now to the location where the server specified to go and actually perform that redirect. Or whatever other status codes. So if we got a 500, we'd probably just print that out to standard error or something like that, or render the appropriate 500 page or 404, whatever. And then finally, under here at step 8, once we've determined that we don't need to perform any redirects or anything like that, here we're now going to store the resource that we got from the server in the cache. So that next time we want to access this resource again, we can skip all of this and just find it in the cache and not have to go through all that again. Decoding the response. So for example, if it's compressed, the browser will uncompress that. Step 10 determines what to do with the response. So here maybe it will be like, this is where now the browser needs to take into account what is the type of the data we got back, right? So is it an HTML page? Is it plain text? Is it a JPEG image? Is it a video MP4 file? Whatever. it needs to handle those differently. But of course, browsers are really good at that. And then it'll just follow through then lastly on that particular action that it needs to perform in response to whatever the content type was of the data that it got back from the server. So again, that's the overarching flow of what happens. I was gonna say, like, I don't think it's a good idea to kind of just memorize this list, because this is occasionally uh, an interview question that does get asked. I don't think it's that common, but I think it does happen. And I certainly remember it because I ran into this particular Stack Overflow post when I was doing my boot camp as well. And I certainly remember at that time just being, after I was told that this is an interview question that sometimes gets asked, I certainly tried my darndest to just memorize this stinking list. But I don't think it served me particularly well in that particular case. Because unfortunately, the problem with just memorizing a list like this is, sure, you can maybe say the words if you actually do memorize it, but you don't really like understand what each of these lines means. But you're all adults. I'm gonna leave that choice up to you. Certainly, again, in the long term, it's better to kind of like understand what each of these lines means, and then that kind of obviates the need to even memorize this list. But that being said, perhaps in the short term, memorizing this list works for you. Again, I don't even really think it needs to happen. I don't think that this particular question gets asked a lot. Maybe you'll run into a situation where it gets asked you and you didn't memorize it, and well, maybe you bombed that interview as a result. But you're gonna bomb interviews anyway, so I don't know. it's a judgment call on your part. Put out flashcards, the most important things to memorize. Yeah, possibly. But honestly, even if that does happen, I wouldn't even really rank this particularly highly. It's certainly something, if you're working in a web context, it is something you should be familiar with. That being said, I don't know how. I don't think it gets actually explicitly asked in an interview that often. And again, certainly I would advocate more for like kind of understanding what each of these parts is doing, and kind of just building up this mental model in your head of generally speaking how the internet works, which again will kind of obviate the need to actually memorize this list. But I certainly can empathize with, again, first encountering this material. That's like, it takes time to build up that mental model of how the internet works. And if you kind of need to, be able to explain this stuff more in the short term, memorization is kind of the more direct route to that. But again, I'm going to leave that judgment call up to you. So let's take a 5-minute break. But before we do that, as far as what I was just talking about, kind of building up your knowledge base and kind of slowly building up a mental model for how the internet works, short of taking like a university networking class. I do have one particular resource. What was it? I think I had it. Yeah, here. So this, I think this is just like some sort of white paper that they probably used in the, like the introductory networking class at Stanford. But this thing is great. It's pretty thorough, goes through kind of everything we kind of talked about in more detail than we talked about. Um, so if you kind of want to inform yourself, this is this might be your one-stop shop resource for doing that. So, and plus, I don't think it's not a very hard read, I think. Well, what do I know? Okay, so let's take a 5-minute break. All right. So let's come back and let's dive a bit more into kind of what you'll be doing in the first 2 days of this particular project. So again, the first 2 days is where we'll go about actually building the, I guess I would say the bare bones functionality. Days 3 and 4, the latter half of the week, will kind of be augmenting the server again with caching functionality. I certainly wouldn't consider that to be the MVP part of the server for sure. Right, the MVP part of the server is just it needs to be able to receive a request and send a response in response to that request back to the client. So again, that's what we'll be doing on days 1 and 2. So if we haven't looked at the code yet, we could look at the skeleton code, but sure, let's do that. So we go in. Oh, sorry. One thing I do want to say first. Kind of one of the main objectives, and this wasn't really, I guess, stated in the training kit or in any of the videos, but I guess kind of one of the secondary objectives of this particular project is literally to drop you guys into a foreign code base where there's a lot of code written already that you didn't implement, that you could probably spend a lot of time just reading to try to understand, right? And frankly speaking, that's a pretty common scenario, right? Most of the time, and I know with a lot of the previous projects that you guys have worked on, those were pretty much all kind of like greenfield projects. And what greenfield means is you were essentially the first engineer. Like that's basically what that was emulating, right? Like nobody had really worked on the project very much before you came along, and then you were tasked with implementing these particular pieces of functionality or whatever. And you kind of just had, for the most part, a blank slate to kind of do that in. So maybe architecture might have been a little bit of an exception. So I guess architecture, I think, kind of falls into this objective as well. But I think certainly the web server project, I think we'll get more of that. We'll get even more of that essentially, right? Because just looking at what we already have in here, you'll be working in the server.c file for the first 2 days. But all these other files, for the most part, have stuff in them already. You don't really need to like touch a lot of these. But that being said, they all provide some functionality that's used in the server. I think, right? But again, that's a very realistic scenario, and it's certainly probably one you're going to encounter when you start your first job, right? It's very, very unlikely that you're going to be the first engineer at whatever company hires you, right? 99% of the time, there's going to be other engineers that started working before you. There's going to be lots of code that they already wrote that, on the first day of your new gig, I guess, a lot of what you're going to be doing is kind of getting up to speed on what's been done already, what needs to be done, and kind of where you fit in and where you want to make most of your code changes. Right. So that's kind of one of the objectives that's being emulated here with this particular project. And I would say this is probably I would certainly think that this is actually harder than what you would encounter on the first day of some job that you start, because I feel like for the most part, when you guys start a new job, you're not going to be working in a giant C code base. At least I would think. Uh, I imagine most of you are going to be working in a JavaScript or perhaps a Python one. Um, More likely it's going to have multiple languages, but you guys are probably going to, for the most part, start off in either most likely JS, I think, perhaps Python, if you really feel like going that direction. Um, but I highly doubt any of you are going to be working in a giant C code base, right? So in that sense, this is going to be probably a little more difficult than what you would encounter on your own actual first day. But I think that's a good thing. Again, within you're still here at Lambda, you're still in a learning environment. I think we can you can afford to fail here, way more so than you can afford to fail on your first day at a new job, right? When there are expectations riding on you, and someone's actually paying you to do this work. We certainly don't want that to be the first time you encounter that particular scenario and not know how to handle it, right? So yeah, keep in mind that's one of kind of the secondary objectives of this particular sprint. It's intentional. We want to give you guys practice experiencing that. And yes, certainly it's going to be difficult because this is a giant C code base in a language that you guys probably, I would gander to say, feel the least comfortable in. But everyone's going to get past that. You're all going to get through this sprint, and after that you'll have done it before, and it most likely will have been tougher than it would actually be on your first day on an actual job. All right. So as I said, for the first 2 days, you're pretty much going to be in server.c. And if you haven't looked at this yet, there's a lot of code in here already. I don't know if there have been any other projects where there was this many included header files. Again, I'm not too familiar with the architecture code base, so maybe I'm wrong. But just going in here and looking at the function signatures we have available, send response. So this is going to be the function where the server has already parsed the request and knows the data it needs to send in response to that request. This is the function that pretty much takes that data, formats it correctly into what a request is supposed to look like, and then actually sends it along via the send system call. Get D20 is a function that handles the D20 endpoint. Pretty much here is where you would generate the random logic of generating the random number, and then call send response with the data. So that send response then will again take that data, format it into the correct response format, and then actually send it. And response 404 is when this is for sending a 404 page, HTML page. So when the client requests something the server isn't able to serve, this is the function that handles that. So this is a good model to since this is already here, you'll have an idea of what get D20 should look like. It should be relatively similar to this response 404, since they're both functions for handling specific responses. Let me get back to get file in a second. Find start of body is a stretch goal. So let's not talk about that one quite yet. And then here we have the handle HTTP request. This is where the logic goes for actually parsing the request. So the request is going to come in, and then in this particular function, you'll need to essentially tokenize the request, essentially break that down into its separate pieces, right? So again, because what a request looks like is, if we go look here real quick, so we look at an example of an example request, it'll pretty much look like this, right? So there's a couple of pieces that we need to take into account when we look at this request. So first off, the get here is important. We're certainly going to need that. Slash example, the path, we're probably going to need that. HTTP 1.1/1.1, we don't really need that. Every single request that comes in is going to have this, but that doesn't actually really provide us important information. Then the host, well, we don't actually need this either as far as the server is concerned, because this was important in order for the request to actually get to our server. But once that it's actually gotten to our server, I guess really all we need are these first two pieces of information. So we know that it's a GET request, and we know specifically the path that's being requested or the resource that's being requested through this path URL. So when you go and implement the handle HTTP request function here, and it receives that request string, it's going to get that whole thing, but you essentially need to break it down into individual string tokens. And as far as how to actually do that, clear this. I think this particular function is going to be useful on that front. So this function called sprintf, which is a variant on printf. But basically what this does, the description here doesn't make a lot of sense. I think it makes more sense when you go and look at the example that they have. So what sprintf does, we just look at the code that we have here. So first off, they start off with a string buffer with 80 spots in it. And then they call sprintf. First, they specify the string buffer. So we want, this is where the output is basically going to be in this str buffer. Second part, then this entire part is the format that we want it to be in, and then any data we need to pass into that format. So basically what they want to do here is they want to put the string of this format into the str buffer, and they want to fill in this value here with this value, with the value of pi. And then they basically print it out. So then this is what actually gets injected into the str buffer. It's kind of C's version of string concatenate. I don't think you would actually use this for concatenation. Not quite concatenation. I think of it more as like injection. Because again, you initialize the buffer beforehand. You call sprintf on that buffer, but then here in the next couple of arguments, this is where you specify exactly how I want the string to be formatted. right? So basically what sprintf is doing is it's giving you the ability to write formatted output into a string buffer, into some arbitrary string buffer, instead of to standard output like what you would with just sprint with just the normal printf. Okay, so what you'll be doing then, in order to actually tokenize the request, uh, you'll likely want to use this. I'm not going to spoil exactly how to use that. I'm going to let you guys figure that out. But this will be handy. So again, you get the request, you tokenize that into the bits, into the individual tokens that you need. So again, kind of just the method, the get, or it could be a post, and then the URL, because the path, because that tells you which endpoint needs to be, which endpoint function needs to be called. So again, once you've tokenized them, then you can do a big if-else branch just to check that is this requesting a /d20? If it is, then I can call that get d20 endpoint, for example. Or if it's asking for something else like index HTML, I can handle that, et cetera, et cetera. Okay, one other thing. So we've talked about these first three. Are there any questions so far on what we've talked about so far? Again, just to run it down again, handle HTTP request is basically the function where you write the logic for actually having the server parse the request. Again, the request is going to come in, you're going to tokenize it, essentially break that string down into the relevant pieces that you actually need, and then figure out how you want to handle that request in turn. So basically, by the end of handle HTTP request, it's going to go and call, for example, get d20 if they gave you the /d20 path. So again, d20 is just going to be the function that performs the actual random number generation. Again, this is not actually responsible for sending the response. That happens in send response here. So then send response is responsible for whatever data your server has figured out it needs to send, taking that, constructing the actual response string in the correct format, and then actually calling the send system call to actually send that down the connection, right? So this is for handling the incoming request. This is for handling outputting the response. This one is handling one of the actual endpoints. But then there's one more, implementing arbitrary file serving. So basically what this means is, oh, okay, that's why the server broke, I think. Okay, anyways, so again, we start up the server. I think what you'll notice is there is a get D20 for handling the slash D20, but there's no endpoint for just handling the home route. So what's supposed to happen then during the home route is well, really, so I think I'm wondering if the server broke because I actually don't think it's supposed to be able to handle just slash, because I gave it just this. But I think what it needs is the index HTML. I guess I'm not sure if it's able to handle just that. Even though it turns out, so being able to handle localhost 3490 slash is a stretch goal, the number 2 stretch goal here, to implement automatic index HTML serving, such that when the user gives you 3490 slash, it will basically default to this 3490 slash index HTML. So the idea then is, so maybe let's do that correctly. So once we do that, nope, just kidding. It's another issue. We can go and request this file, right? And this is going to be a file that is just in the directory structure here in the server's directory structure. I think here in server file, no, that's the 404. So here in the server root, here's the index HTML. We can just go and request that like we did here. Or we could give it some other file. But foobar is not a thing. Oh, right, I didn't have the server up. So we hit foobar HTML. The server will look through all the files it has available to it. And once it realizes it doesn't have this, it will go and default to sending the 404 not found, the 404.html page. The other one in server files. So this one. And that's a pretty common piece of functionality that servers do is file serving, right? Should have turned that off. I don't know if I can. So that's what's going to happen here in this get file function. We've done some file I/O before, but this is where it'll be put to kind of a more practical use case. Let's see if there is. But yeah, so with that, you'll likely want to use the It doesn't want to use the read system call, or is that right? You know what? Let's save talking about this particular one for tomorrow. It is the last one, the last part. The file serving is the last bit that you guys will work on. So I think if we talk about that tomorrow, it'll probably still, yeah, we'll talk about that tomorrow. As far as some, let's talk a bit about some other handy string manipulation functions that you guys might find useful. So there's this one called strtok, which I guess stands for like string token or something like that. This is essentially your good old string.split function from JS. I think it pretty much has the same signature as well. You give it the string, and you give it the delimiter, and it will then split that string for you along that delimiter. Although what's interesting is that with this one, it doesn't put them all in an array for you. It actually just returns another string and basically like literally just splits those up for you. So it just returns for you another char star string instead of returning all of those separate pieces for you in an array, which would probably be easier to work with. But anyways, so that is available. There's also, I don't know if you guys have seen these before, but quick refresher if you have. strchr, this is for specifically finding a character inside of a string, finds the first instance. So it finds the first instance of whatever character you give it as input in the string, and then returns to you a pointer to that string. So if we look at the example here, tutorialspoint.com as the string that they're going to search through, then they're going to find the first instance of a period. So that should give us right here. And then they allocate a separate pointer. So this is going to be the variable it's going to store the return value of strchr here, as we see. So that then basically what's going to be stored in this pointer is this period location. Or if we want to kind of visualize that, clear this. They had they had www. Right, so they call strchr with the string and period. So basically what happens then, and we had the char star, we call it RET. So this function will search through, look at every character, finds the first instance of the period, And then once that happens and it returns, this pointer will now point to the spot in the string. And then similarly, there's also the str, which is instead of just finding a single string element or a single character element, finds an entire string. So here in this example, tutorials point, and they want to find point, and this will put the pointer, the RET pointer, at the beginning of this string in the larger string, right? So basically, once this function returns, RET is going to point to this P. So just the beginning of that needle string that we were looking for. I'm just telling you guys all this just because really kind of the biggest part of this particular web server sprint is kind of a lot of string manipulation and parsing strings and tokenizing them and constructing constructing the response. It's pretty much a lot of string manipulation. A lot of the networking stuff, all the networking stuff has already been implemented for you, so you don't need to actually implement any of that. If you look here, the logic to actually get the socket, that actually where you send the data down, is already been implemented. That's all in the net.h and net.c files. Of course, you can feel free to take a look in there. It's pretty well commented, but otherwise it's, strictly speaking, stuff you don't actually really need to know how that works in order to get the web server to work. You already have the file descriptor for the socket, and all you have to do from that is read from it and send data down it in order to actually communicate between the client and the server. Okay, I think that's all I wanted to say for the first day. So I think we can go and let you guys get started. Get your feet wet with it. I'm sure more questions are going to pop up as you guys actually start working in the code. I know when we're just kind of like looking at it and talking through it together, maybe it's harder to formulate questions. But again, I'm sure questions are going to come up when you guys actually start working in it. So when that happens, again, please use the help channels. Or, well, you can ask your PMs, of course. But I think in the case that your PM isn't able to answer, then please reach out in the help channels. I know I'm beating a dead horse talking about this stuff, but really I feel like it always serves as a good reminder. I think you guys already have the repository link, but I can make it one more time just in case. But yeah, so let me let you guys go a bit early. Go ahead and get started. And tomorrow, we definitely said we'd talk about file serving more, so that's on the docket. I'll probably also do some of the solution tomorrow during lecture as well, during the morning lecture. and then we'll probably do a solution lecture tomorrow afternoon to get through the rest of it before we start days 3 and 4. So solution lecture tomorrow afternoon will just cover or finish up days 1 and 2. Obviously not 3 and 4. All right. Yeah, let you guys get started then, if there are no more questions. If not, I will talk to you all later then. Cool. Good luck, guys. I'll talk to you later.